Hello students, today in this video we will study the MCQs on moving charges and magnetism. First question is the concept that moving charges or current produce a magnetic field was discovered by. This was discovered by H.C. Ørsted. In his experiment, what he observed is when the current was flowing through the wire, a magnetic needle which was placed near this wire, it got deflected. When the current was flowing from north to south, the north pole of the magnet, it got deflected towards east. Similarly, when the current was flowing from south to north, the magnetic needle got deflected towards west. And the deflection, it was depending on the strength of the current and the distance from the wire to the magnetic needle. When the current was increased, the deflection in the magnetic needle got increased. When the distance was decreased, then also the deflection in the magnetic needle got increased. And when the current was zero, the magnetic needle came back to its original position. These were some of the observations made in his experiment. And this discovery gave the first empirical evidence of a connection between electric and magnetic phenomenon. Okay, option D is the correct answer, Ørsted. Next, second question. Second question is magnetic field is a vector quantity because magnetic field is having both magnitude and direction. Option B is the correct answer. Next, question number 3. Question number 3 is how much force will be experienced by a moving charge in magnetic field? The symbols have their usual meaning. ಇವಾಗ ಒಂದು ಚಾರ್ಜ್ ಪಾರ್ಟಿಕಲ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಒಳಗೆ ಮೂವ್ ಆಗ್ತಾ ಇದ್ರೆ when it is moving in a magnetic field with some velocity v, this charged particle will experience a force. That force is given by vector F is equal to q into vector v cross vector b. This force is called as a magnetic force experienced by the charged particle moving in a magnetic field. Here option D is the correct answer. Vector F is equal to q into vector v cross vector b. Next, question number 4. Question number 4 ಏನಿದೆ ನೋಡ್ರಿ. Question number 4 is force on a charged particle moving in a magnetic field is maximum when the angle between velocity of the charge and the magnetic field is. ಇವಾಗ ಈ force value it is given by F is equal to q v b sin theta. Force value ಯಾವಾಗ ಮ್ಯಾಕ್ಸಿಮಮ್ ಆಗುತ್ತೆ ಅಂದರೆ when sin theta is maximum when theta is equal to 90, sin theta is equal to 1, ಆವಾಗ ಫೋರ್ಸ್ ವ್ಯಾಲ್ಯೂ ಏನಾಗುತ್ತೆ ಮ್ಯಾಕ್ಸಿಮಮ್ ಆಗುತ್ತೆ. ಫೋರ್ಸ್ ವ್ಯಾಲ್ಯೂ ಮಿನಿಮಮ್ ಯಾವಾಗ ಆಗುತ್ತೆ ಅಂದರೆ when theta is equal to 0 or 180, sin 0 or 180 sin theta ವ್ಯಾಲ್ಯೂ ಏನಾಗುತ್ತೆ equal to 0, ಆವಾಗ ಫೋರ್ಸ್ ವ್ಯಾಲ್ಯೂ ಏನಾಗ್ತೈತೆ ಮಿನಿಮಮ್. Here they have asked force will be maximum when the angle between velocity and magnetic field is equal to ಎಷ್ಟು 90 ಡಿಗ್ರಿ ಇರಬೇಕು ಅಥವಾ ವೆಲಾಸಿಟಿ ಮತ್ತು ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಎರಡು ಒಂದಕ್ಕೊಂದು ಹೆಂಗಿರಬೇಕು ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಆಗಿರಬೇಕು. ದೆನ್ ದ ಫೋರ್ಸ್ ವಿಲ್ ಬಿ ಮ್ಯಾಕ್ಸಿಮಮ್. ಸೊ ಆಪ್ಷನ್ ಬಿ ಈಸ್ ದಿ ಕರೆಕ್ಟ್ ಆನ್ಸರ್, 90 ಡಿಗ್ರಿ. ಇದೇ ಕ್ವಶನ್ನ ವೆನ್ ದ ಫೋರ್ಸ್ ವಿಲ್ ಬಿ ಮಿನಿಮಮ್ ಅಂತ ಕೇಳಿದಾಗ ದ ಆ್ಯಂಗಲ್ ಮಸ್ಟ್ ಬಿ ಈಕ್ವಲ್ ಟು 0 ಆರ್ 180 ಆರ್ velocity of the charged particle must be parallel to the magnetic field or it should be anti-parallel to the magnetic field. ಆವಾಗ ಫೋರ್ಸ್ ವ್ಯಾಲ್ಯೂ ಏನಾಗುತ್ತೆ ಮಿನಿಮಮ್ ಆಗುತ್ತೆ. ನೆಕ್ಸ್ಟು ಫಿಫ್ತ್ ಕ್ವಶನ್ ಇದೆ ನೋಡ್ರಿ. A strong magnetic field is applied on a stationary electron. Then the electron, ಇವಾಗ ಎಲೆಕ್ಟ್ರಾನ್ ಸ್ಟೇಷನರಿ ಇದೆ ಅಂತಂದರೆ the velocity of electron is equal to ಎಷ್ಟು 0. When velocity is equal to 0, then the force acting on the electron will also be equal to 0. The force expression is F is equal to qvb sin theta. Electron stationary ಇದೆ ಅಂತಂದರೆ velocity is equal to 0. Velocity 0 ಇದ್ದಾಗ force value ಏನಿರುತ್ತೆ 0 ಇರ್ತದೆ. When force is 0, initially the electron is stationary and it remains in the stationary state only. So option C is the correct answer, remains stationary. Next, question number 6. Work done by magnetic force on a charge moving in a uniform magnetic field is 0. ವರ್ಕ್ ಡನ್ ವ್ಯಾಲ್ಯೂ ಏನಿರುತ್ತೆ, ವರ್ಕ್ ಡನ್ ಈಸ್ ಈಕ್ವಲ್ ಟು 0. ಯಾಕೆ ಅಂತಂದರೆ ಹಿಯರ್ ದ ಫೋರ್ಸ್ ಆ್ಯಂಡ್ ವೆಲಾಸಿಟಿ ದೇ ಆರ್ perpendicular to each other. Here the force is the vector product of vector v and vector b, q times vector v and vector b. Hangidre it is given by right hand thumb rule. Here the fingers, these fingers indicates the direction of velocity, thumb indicates the direction of force, and in which direction we are going to close the fingers, that will give the direction of magnetic field. ಹಂಗಿದ್ರೆ ಈ ವೆಲಾಸಿಟಿ ಮತ್ತು ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡು ಎರಡು ಫೋರ್ಸ್ ಹೆಂಗಿರುತ್ತೆ, ದೇ ಆರ್ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಟು ಈಚ್ ಅದರ್. ವೆನ್ ಫೋರ್ಸ್ ಆ್ಯಂಡ್ ವೆಲಾಸಿಟಿ ಆರ್ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಟು ಈಚ್ ಅದರ್, ದೆನ್ ದ ವರ್ಕ್ ಡನ್ ಬೈ ದ ಚಾರ್ಜ್ ಪಾರ್ಟಿಕಲ್, ಓಕೆ, ವರ್ಕ್ ಡನ್ ಬೈ ದ ಫೋರ್ಸ್ ಆನ್ ದ ಚಾರ್ಜ್ ಪಾರ್ಟಿಕಲ್ ಈಸ್ ಈಕ್ವಲ್ ಟು ಏನಾಗುತ್ತೆ, 0 ಆಗ್ತೈತಿ. Option A is the correct answer. Vector F is perpendicular to vector V. Next question number 7. Question number 7 ಏನಿದೆ, ಯೂನಿಟ್ ಆಫ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಇನ್ ಟರ್ಮ್ಸ್ ಆಫ್ ಬೇಸ್ ಯೂನಿಟ್. ಯೂನಿಟ್ ಆಫ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಏನಾಗುತ್ತೆ, ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಎಕ್ಸ್ಪ್ರೆಷನು B is equal to ಏನಾಗುತ್ತೆ, F divided by Q into V. Here the unit of force is Newton, unit of charge is Coulomb, velocity meter per second. ಹಾಗಿದ್ರೆ ಇವನ್ನೆಲ್ಲ ನಾವು ನ್ಯೂಮರೇಟರ್ ಒಳಗೆ ತೊಗೊಂಡಾಗ ಏನಾಗುತ್ತೆ, ನ್ಯೂಟನ್ ಪರ್ ಕೂಲಂಬ್ ಪರ್ ಮೀಟರ್ ಸೆಕೆಂಡ್ ಆಯ್ತು. ದಿಸ್ ಇಂಪ್ಲೈಸ್ ವಿ ಕ್ಯಾನ್ ರೈಟ್ ಇಟ್ ಆಸ್ ನ್ಯೂಟನ್ ಸೆಕೆಂಡ್ ಪರ್ ಕೂಲಂಬ್ ಪರ್ ಮೀಟರ್. Per coulomb second we can write it as per ampere. Then we get Newton per ampere per meter. The unit of magnetic field is Newton second per coulomb per meter or Newton per ampere per meter. Here in this case they have given Newton second per coulomb per meter. Option A. Option A is the correct answer. Next question number 8. Under which condition a particle will experience a force in a magnetic field? Option A ಏನು ಕೊಟ್ಟಿದ್ದಾರೆ, it should be an electrically charged particle. That means the charge of the particle must not be equal to 0. That means the particle should be an electrically charged particle ಇರಬೇಕು. Second option ಏನು ಕೊಟ್ಟಿದ್ದಾರೆ, it should move with certain velocity. That means V must not be equal to 0. The charged particle should be in the state of motion. Third option, option C ಏನಿದೆ, direction of velocity of charged particle must make an angle with a magnetic field other than 0 or 180. Theta value ಏನಿರಬಾರ್ದು, theta value must not be equal to 0 or 180 degree. ಆವಾಗ ಏನಾಗುತ್ತೆ, this charged particle or this particle will experience a force in a magnetic field. All the above conditions must be satisfied. Option D. Option D is the correct answer. Q must not be equal to 0, V must not be equal to 0, theta must not be equal to 0 or 180 ಅಂತ ಕೊಟ್ಟಾರೆ ಆಪ್ಷನ್ A, B, C ಒಳಗೆ. ಸೊ ಆಪ್ಷನ್ D, all the above conditions must be satisfied. Option D is the correct answer. Question number 9 ಇದೆ ನೋಡ್ರಿ, when the charged particle move in a combined magnetic and electric field, then the force acting on it is known as. ಇವಾಗ ಒಂದು ಚಾರ್ಜ್ಡ್ ಪಾರ್ಟಿಕಲ್, ಇಟ್ ಇಸ್ ಮೂವಿಂಗ್ ಇನ್ ಬೋತ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಆ್ಯಂಡ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್. ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡು ಮತ್ತು ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಒಳಗೆ ಮೂವ್ ಆಗ್ತಾ ಇರಬೇಕಾದ್ರೆ ದೆನ್ ದ ಫೋರ್ಸ್ ಆ್ಯಕ್ಟಿಂಗ್ ಆನ್ ದ ಚಾರ್ಜ್ ಪಾರ್ಟಿಕಲ್ ಈಸ್ ಕಾಲ್ಡ್ ಆಸ್ ಲಾರೆಂಟ್ಸ್ ಫೋರ್ಸ್. ಆಪ್ಷನ್ ಎ ಈಸ್ ದಿ ಕರೆಕ್ಟ್ ಆನ್ಸರ್. ನೆಕ್ಸ್ಟ್ ಕ್ವಶನ್ ನಂಬರ್ 10 ಇವರು. ಕ್ವಶನ್ ನಂಬರ್ 10 ಏನಿದೆ, ಲಾರೆಂಟ್ಸ್ ಈಕ್ವೇಷನ್ ಈಸ್ F is force, Q is charge, E is electric field, B is magnetic field, V is velocity of the charged particle. It is given by the Lorentz force is the force acting on the charged particle by electric field as well as magnetic field. ಇವಾಗ ಒಂದು ಚಾರ್ಜ್ ಪಾರ್ಟಿಕಲ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಒಳಗಿದ್ದಾಗ this charged particle will experience a force. It is given by Q into E, where Q is the magnitude of charge, E is the electric field, plus this charged particle when it is in the state of motion in the magnetic field, it will experience a force. That force is given by Q into vector V cross vector B. then the expression for Lorentz force is given by Q into vector E plus Q into vector V cross vector B. Option D is the correct answer. Next question number 11 ಗೆ ಬರೋಣ. Question number 11 ಇದೆ dimension of Q into vector E plus Q into vector V cross vector B is. This equation is equal to the equation of a force. ಹಾಗಿದ್ರೆ this equation should have the same dimension as the dimension of force, that is equal to m raised to 1, L raised to 1, T raised to minus 2. Option B is the correct answer. Next question number 12 ಬರೋಣ. Question number 12 ಏನಿದೆ? A charged particle enters an electric field in the direction of electric field. What is the nature of the path traced by it? ಇವಾಗ ಒಂದು ಚಾರ್ಜ್ ಪಾರ್ಟಿಕಲ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡನ್ನು ಎಂಟರ್ ಆಗ್ತದೆ ಆ್ಯಂಡ್ ದಿಸ್ ಚಾರ್ಜ್ ಪಾರ್ಟಿಕಲ್ ಈಸ್ ಎಂಟ್ರಿಂಗ್ ದ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಇನ್ ದ ಡೈರೆಕ್ಷನ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್. ಆವಾಗ ದಿಸ್ ಚಾರ್ಜ್ ಪಾರ್ಟಿಕಲ್ ವಿಲ್ ಎಕ್ಸ್ಪೀರಿಯನ್ಸ್ ಅ ಫೋರ್ಸ್. ದಟ್ ಫೋರ್ಸ್ ಈಸ್ ಗಿವನ್ ಬೈ ವೆಕ್ಟರ್ ಎಫ್ ಈಸ್ ಈಕ್ವಲ್ ಟು ಕ್ಯೂ ಇಂಟು ವೆಕ್ಟರ್ ಇ. ಇಫ್ ದ ಪಾರ್ಟಿಕಲ್ ಈಸ್ ಅ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಪಾರ್ಟಿಕಲ್, it will experience the force in the direction of electric field. Means if the particle is a positive charge. Similarly, if the particle is a negative charge particle, it will experience a force opposite to the direction of electric field. In both the cases, the force will be acting along the straight line. So the particle will move along the straight line. The path traced by it will be a straight line path. Option A is the correct answer. Next question number 14 ಇವರ sorry not question number 13 ಇವರ. Question number 13 ಏನಿದೆ? A uniform electric field and a uniform magnetic field are acting along the same direction. Uniform electric field and uniform magnetic field, they are acting along the same direction in certain region. If an electron is projected in the region such that its velocity is pointed along the direction of magnetic field. You want charge particle, okay, that is the electron. Okay, an electron is projected in the direction of this electric field and magnetic field. That is the velocity of the electron is in the direction of electric field and magnetic field. Avaga then the electron. ಇವಾಗ ಎಲೆಕ್ಟ್ರಾನು ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಒಳಗೆ ಮೂವ್ ಆಗಬೇಕಾದ್ರೆ ದಿಸ್ ಎಲೆಕ್ಟ್ರಾನ್ ವಿಲ್ ಎಕ್ಸ್ಪೀರಿಯನ್ಸ್ ಅ ಫೋರ್ಸ್ ಆಪೋಸಿಟ್ ಟು ದ ಡೈರೆಕ್ಷನ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್. ದಿಸ್ ಫೋರ್ಸ್ ವಿಲ್ ಬಿ ಆಪೋಸಿಟ್ ಟು ದ ಡೈರೆಕ್ಷನ್ ಆಫ್ ದಿಸ್ ವೆಲಾಸಿಟಿ. ಸೊ ದ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಸ್ಪೀಡ್ ವಿಲ್ ಡಿಕ್ರೀಸ್. ಸ್ಪೀಡ್ ಏನಾಗುತ್ತೆ? ಡಿಕ್ರೀಸ್ ಆಗುತ್ತೆ ಡ್ಯೂ ಟು ದಿಸ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್. Similarly, this electron is moving in a magnetic field. This is moving, the velocity of the electron and the magnetic field are along the same line, theta equal to 0. Then the force acting on this electron by the magnetic field is equal to 0. Here, this electron will experience the force only by this electric field, which is opposite to the direction of velocity. So, the speed of the electron will decrease. Option B is the correct answer. Speed will decrease. Next question number 14. Question number 14 ಏನಿದೆ? Force acting on a charged particle moving in a magnetic field is 0. ಇವಾಗ ಒಂದು ಚಾರ್ಜ್ ಪಾರ್ಟಿಕಲ್ ಕೊಟ್ಟಿದ್ದಾರೆ. This charged particle is moving in a magnetic field. Okay, it is moving in a magnetic field. When the force is equal to 0 ಅಂತ ಕೇಳಾರೆ. Force ಯಾವಾಗ 0 ಇರ್ತದೆ ಅಂದರೆ this charged particle must move parallel to the magnetic field or anti-parallel to the magnetic field. That means theta must be equal to 0 or 180 degree. That means velocity of the charged particle must be parallel or anti-parallel to the magnetic field. Here option A is the correct answer. The charged particle moves parallel or anti-parallel to the magnetic field, then the force will be equal to 0. Next question number 15. Question number 15 ಏನಿದೆ ನೋಡ್ರಿ. A neutron moves with a uniform velocity at an angle of 90 degree to a uniform magnetic field, its path will be. ಇವಾಗ the charge of the neutron is equal to 0, then the force acting on the neutron will also be equal to 0. Force 0 ಆದಾಗ the electron will not change its direction, so the electron will move along a straight line. Option D is the correct answer. Next question number 16 ಇವನ question number 16 ಏನಿದೆ? A proton is kept in a uniform magnetic field. The proton, here the proton is kept in a magnetic field means the velocity of proton is equal to 0, then the force acting on the proton will also be equal to 0. The electron is stationary and it remains stationary, it will not move. Option D is the correct answer. Next question number 17 ಇವನ question number 17 ಏನಿದೆ? A charged particle moves parallel or anti-parallel to the magnetic field. That means the charged particle moving with an angle of theta equal to 0 or 180 degree. Parallel or anti-parallel to the magnetic field. Then the charged particle will move along the straight line because no force is acting on the charged particle. The force is equal to 0. Force 0 ಇದ್ದಾಗ charged particle ಯಾವ ರೀತಿ ಮೂವ್ ಆಗುತ್ತೆ? The charged particle moves along a straight line path. Option D is the correct answer. Next ಇವಾಗ question number 18 ನೋಡ್ರಿ. question number 18 ಏನಿದೆ? A charged particle moves perpendicular to a magnetic field. Its path will be. ಇವಾಗ ಒಂದು charged particle, if it is moving perpendicular to the magnetic field, here the angle is equal to ಎಷ್ಟು? Theta is equal to 90 degree. Sin 90 is equal to 1. Then the force acting on the charged particle is maximum. ಆವಾಗ ಚಾರ್ಜ್ ಪಾರ್ಟಿಕಲ್ ಹೆಂಗೆ ಮೂವ್ ಆಗುತ್ತೆ ಅಂದರೆ ಇಟ್ ಮೂವ್ಸ್ ಇನ್ ಎ ಸರ್ಕ್ಯುಲರ್ ಪಾತ್. ಓಕೆ, ಹಿಯರ್ ಆಪ್ಷನ್ ಎ ಇಸ್ ದಿ ಕರೆಕ್ಟ್ ಆನ್ಸರ್. ಆಪ್ಷನ್ ಎ, ಅ ಸರ್ಕಲ್, ಇಟ್ ಮೂವ್ಸ್ ಇನ್ ಅ ಸರ್ಕ್ಯುಲರ್ ಪಾತ್ ವೆನ್ ದ ಚಾರ್ಜ್ ಪಾರ್ಟಿಕಲ್ ಇಸ್ ಮೂವಿಂಗ್ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಟು ದಿ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್. ನೆಕ್ಸ್ಟು 19th ಕ್ವಶನ್. ಕ್ವಶನ್ ನಂಬರ್ 19 ಏನಿದೆ? ಅ ಚಾರ್ಜ್ ಪಾರ್ಟಿಕಲ್ ಮೂವ್ಸ್ at an angle of theta to a magnetic field. Theta not equal to 0, not equal to 180 and not equal to 90. Then its path is. ಇವಾಗ ಒಂದು charged particle, it is making some angle here with the magnetic field. It is making an angle theta. This theta is not equal to 0, theta is not equal to 180 and theta is not equal to 90 degree. ಆವಾಗ ಚಾರ್ಜ್ ಪಾರ್ಟಿಕಲ್ ಯಾವ ರೀತಿ ಮೂವ್ ಆಗುತ್ತೆ ಅಂತ ಕೇಳಿದ್ದಾರೆ. ದ ಕಂಪೋನೆಂಟ್ ಆಫ್ ವೆಲಾಸಿಟಿ, ದಿಸ್ ಕಂಪೋನೆಂಟ್ ಆಫ್ ವೆಲಾಸಿಟಿ ಅಲಾಂಗ್ ದ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್, ಇಟ್ ಇಸ್ ಗಿವನ್ ಬೈ ವಿ ಕಾಸ್ ಥೀಟಾ. ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಟು ದ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್, ಇಟ್ ಇಸ್ ಗಿವನ್ ಬೈ ವಿ ಸೈನ್ ಥೀಟಾ. ದಿಸ್ ವಿ ಕಾಸ್ ಥೀಟಾ ಈಸ್ ರೆಸ್ಪಾನ್ಸಿಬಲ್ ಫಾರ್ ಲೀನಿಯರ್ ಮೋಷನ್ and v sin theta is responsible for circular motion. The component of this velocity v cos theta will make the electron or the charged particle to move along this direction. This v sin theta, it will make the charged particle to move in a circular path. So here the velocity is having both the components v cos theta and v sin theta. V cos theta is making the charged particle to move in this direction. V sin theta is making the charged particle to make a circle. So this charged particle, it will make a circle as well as it will move in the forward direction. That means the shape what we are getting is a helical shape. Option B is the correct answer. A helix is the correct answer. Option B. Next question number 20. Question number 20 ಏನಿದೆ? When a charged particle is describing a helix in a magnetic field, distance moved by it along the magnetic field during one rotation. ಇವಾಗ one rotation ಆದಾಗ, it is completing one rotation here. One rotation complete ಆದಾಗ, it is covering some distance here. This distance, it is called as pitch. Option B is the correct answer. Pitch. Next question number 21. Question number 21 ಏನಿದೆ? A charged particle moving with a certain speed enters a magnetic field aligned in some other direction to its motion. Now, ಇವಾಗ ಒಂದು ಚಾರ್ಜ್ ಪಾರ್ಟಿಕಲ್ ಈ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡನ್ನು ಎಂಟರ್ ಆಗ್ತಾ ಇದೆ. ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡನ್ನು ಎಂಟರ್ ಆಗಬೇಕಾದ್ರೆ ಇಟ್ ಇಸ್ ಮೇಕಿಂಗ್ ಸಮ್ ಆ್ಯಂಗಲ್ ಥೀಟಾ ಹಿಯರ್. When it is making an angle theta, here the force is acting on the charged particle which is perpendicular to velocity as well as magnetic field. F and V are perpendicular. F and V are perpendicular. ಎರಡು ಒಂದಕ್ಕೊಂದು ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಆಗಿದ್ದಾಗ ವರ್ಕ್ ಡನ್ ಈಸ್ ಈಕ್ವಲ್ ಟು 0. Okay, work done on the charged particle is equal to 0. Work done is equal to 0 means that is change in kinetic energy is equal to 0. Change in kinetic energy 0 ಆಯ್ತು ಅಂತಂದ್ರೆ ಅದರ ಅರ್ಥ ಏನಂತಂದರೆ kinetic energy is constant. When kinetic energy is constant, then the speed of the charged particle, this is also constant. Kinetic energy is constant and speed of the charged particle is also constant. But the direction of the charged particle is changing. In this case, its speed changes, its kinetic energy changes and the option A, its speed changes and the quarter. That's wrong. Kinetic energy changes and the quarter. That is also wrong. Option C nodri, direction of motion changes. Kinetic energy and its speed does not changes, but the direction of the charged particle will change there. Option C is the correct answer. Next to question number 22. Question number 22 ಏನಿದೆ? A neutron, a proton, an electron and an alpha particle enter a region of uniform magnetic field with the same velocity. The magnetic field is perpendicular and directed into the plane of the paper. Okay, the magnetic field is perpendicular and it is directed into the plane of paper they have given. The tracks of the particles labeled in the figure are, here they have given a neutron. Neutron, it is electrically neutral, charge of neutron is 0. They have given a proton. Proton, the charge of proton is equal to plus E. They have given an electron. Electron, the charge of electron is equal to minus E. Next is they have given an alpha particle. Alpha particle. The charge of the alpha particle is equal to plus 2E. These four particles are given. When the charge of the particle is equal to 0, the magnetic field will not exert any force. So, it will move. It will continue to move in along the straight line. ಈ ಕೊಟ್ಟಿರುವಂಥ 4 ಆಪ್ಷನಲ್ಲಿ ಆಪ್ಷನ್ ಸಿ ಅಲ್ಲಿ ಸಿ ಅಬ್ಸರ್ವ್ ಮಾಡಿ. ಸಿ ಪಾರ್ಟಿಕಲ್ ಈಸ್ ಮೂವಿಂಗ್ ಅಲಾಂಗ್ ದ ಸ್ಟ್ರೇಟ್ ಲೈನ್. ಇಟ್ ಇಸ್ ನಾಟ್ ಚೇಂಜಿಂಗ್ ಇಟ್ಸ್ ಡೈರೆಕ್ಷನ್. ದಟ್ ಮೀನ್ಸ್ ಸಿ ಈಸ್ ದ ನ್ಯೂಟ್ರಾನ್ ಹಿಯರ್. ಸಿ ಏನಿದೆ ನ್ಯೂಟ್ರಾನ್ ಐತೆ. ಹಾಗಿದ್ರೆ ಇಲ್ಲಿ ಪ್ರೋಟಾನ್ ಯಾವುದು, ಎಲೆಕ್ಟ್ರಾನ್ ಯಾವುದು, ಅಲ್ಫಾ ಪಾರ್ಟಿಕಲ್ ಯಾವುದು ಅಂತ ಕಂಡುಹಿಡಿಬೇಕು. ಬೈ ಜಸ್ಟ್ ಅಬ್ಸರ್ವಿಂಗ್ ವಿ ಕ್ಯಾನ್ ಫೈಂಡ್ ಔಟ್ ವಿಚ್ ಈಸ್ an electron, because proton and alpha particle both are positively charged. ಎರಡು ಪಾಸಿಟಿವ್ಲಿ ಚಾರ್ಜ್ಡ್ ಇರೋದ್ರಿಂದ ಹಿಯರ್ A and B, this is A, this is B, two particles are moving towards left. ಹಾಗಾದರೆ ಇವೆರಡು ಪಾರ್ಟಿಕಲ್ಸ್ ಯಾವ ಬೇಕು? one should be proton, the other should be an alpha particle. ಹಾಗಾದರೆ ರಿಮೈನಿಂಗ್ ಪಾರ್ಟಿಕಲ್ ಯಾವುದಾಯ್ತು ಹಂಗಿದ್ರೆ? ದ ರಿಮೈನಿಂಗ್ ಪಾರ್ಟಿಕಲ್ ಈಸ್ D. D ಏನಾಗಬೇಕಲ್ಲಿ? D should be an electron. Okay, we can find it by using the right hand thumb rule. Right hand thumb rule ಪ್ರಕಾರ the magnetic field is inward. Magnetic field ಯಾವ ಡೈರೆಕ್ಷನ್ ಆಗಿದೆ? Inward direction. The fingers indicates the direction of velocity. Thumb indicates the direction of force. ಇವಾಗ velocity ಯಾವ ಡೈರೆಕ್ಷನ್ ಒಳಗೈತಿ? Upward. C is moving upwards means all the particles were initially moving in the upward direction. Okay, velocity upward direction. Force should be in the direction of the thumb. Where is the direction of magnetic field? It is inward. So we have to close the fingers in this direction. This gives the direction of the force acting on the positive charged particle. ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಪಾರ್ಟಿಕಲ್ ಮೇಲೆ ಈ ಡೈರೆಕ್ಷನ್ ಒಳಗೆ ಫೋರ್ಸ್ ಆ್ಯಕ್ಟ್ ಆಗುತ್ತೆ. ನೆಗೆಟಿವ್ ಚಾರ್ಜ್ ಪಾರ್ಟಿಕಲ್ ಮೇಲೆ ಫೋರ್ಸ್ ಅದ್ರ ಅಪೋಸಿಟ್ ಡೈರೆಕ್ಷನ್ ಒಳಗೆ ಆ್ಯಕ್ಟ್ ಆಗುತ್ತೆ. ಹಾಗಿದ್ರೆ ನೆಗೆಟಿವ್ ಚಾರ್ಜ್ ಪಾರ್ಟಿಕಲ್ ಯಾವುದಿಲ್ಲಿ ಎಲೆಕ್ಟ್ರಾನ್, ಹಾಗಿದ್ರೆ ಫೋರ್ಸ್ ಅದ್ರ ಅಪೋಸಿಟ್ ಡೈರೆಕ್ಷನ್ ಒಳಗೆ ಆ್ಯಕ್ಟ್ ಆಗಬೇಕು. ದಟ್ ಮೀನ್ಸ್ ಆಪ್ಷನ್ ಡಿ ಇಲ್ಲಿ ಎಲೆಕ್ಟ್ರಾನ್, ಡಿ ಈಸ್ ದ ಎಲೆಕ್ಟ್ರಾನ್ ಹಿಯರ್. ದೇ ಆರ್ ಆಸ್ಕ್ಡ್ the electron will follow the track D track. Option D is the correct answer. ಹಾಗಿದ್ರೆ ಇಲ್ಲಿ ಪ್ರೋಟಾನ್ ಯಾವುದು ಮತ್ತು ಅಲ್ಫಾ ಪಾರ್ಟಿಕಲ್ ಯಾವುದು ಅಂತ ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕು. they are not asked to find out which is proton and which is an alpha particle, but you should be knowing which is a proton and which is an alpha particle. Here the radius of the charged particle, it is given by R is equal to mv divided by Q into B. Here the velocity and magnetic field are same for both proton and alpha particle, but the mass and charge of proton and alpha particle are different. Mass of alpha particle is equal to 4 times the mass of proton. Charge of alpha particle is equal to 2 times the charge of proton. So when we substitute this, we get radius of the alpha particle divided by radius of proton is equal to mass of alpha particle divided by charge of alpha particle into charge of proton divided by mass of proton. Substitute ಮಾಡಿದಾಗ ಏನಾಗುತ್ತೆ, mass of alpha particle is 4 times of mp, ಇದೇನಿದೆ 2 times of charge of the proton, qp divided by mp. mp cancels, qp get cancelled, 2 1s are 2 2s are. That means radius of alpha particle is 2 times the radius of the proton. ಹಾಗಿದ್ರೆ radius of alpha particle is more here. That means B is alpha particle, A is the proton. A is proton, B is alpha particle, C is neutron and D is electron. So in this case they have asked for the electron. For electron it is option D. D is the correct answer. Next question number 23 ಬರೋಣ. Question number 23 ಏನಿದೆ, if a velocity has both perpendicular and parallel components while moving in through a magnetic field, what is the path followed by a charged particle? The charged particle will follow a helical path when it is having a component of velocity along perpendicular as well as parallel to the magnetic field. It will follow the helical path. Option C is the correct answer. Question number 24 ನೋಡ್ರಿ. Question number 24 ಇದೆ, a charged particle experiences magnetic force in the presence of magnetic field. Which of the following statement is correct? The charged particle is experiencing the force here. Force is given by QVB sin theta. The particle is stationary and magnetic field is perpendicular. Particle stationary ಇತ್ತಂತಂದ್ರೆ it will not experience the force. So option A is not correct. Particle is moving and magnetic field is perpendicular. Particle move ಆಗ್ತಾ ಇರಬೇಕು, magnetic field ಏನಿರಬೇಕು, it should be perpendicular. Perpendicular ಇದ್ದಾಗ then the charged particle will experience the force. now ಆಪ್ಷನ್ ಸಿ ಮತ್ತು ಆಪ್ಷನ್ ಡಿ ನೋಡ್ರಿ. ಪಾರ್ಟಿಕಲ್ ಇಸ್ ಸ್ಟೇಷನರಿ ಅಂತ ಕೊಟ್ಟರೆ, ಪಾರ್ಟಿಕಲ್ ಸ್ಟೇಷನರಿ ಇದ್ದರೆ ಫೋರ್ಸ್ 0 ಇರ್ತದೆ. ಫೋರ್ತ್ ಆಪ್ಷನ್ ಡಿ ಏನು ಕೊಟ್ಟರೆ, ಪಾರ್ಟಿಕಲ್ ಇಸ್ ಮೂವಿಂಗ್ ಆ್ಯಂಡ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಇಸ್ ಪ್ಯಾರಲಲ್. ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಪ್ಯಾರಲಲ್ ಇದ್ದಾಗ ಥೀಟಾ 0 ಇರ್ತದೆ, ಸೈನ್ ಥೀಟಾ ವ್ಯಾಲ್ಯೂ ಏನಾಕೈತಿ 0 ಆಗ್ತೈತಿ. In all the 4 cases, option B is the correct answer. The particle is moving and the magnetic field is perpendicular to the velocity. Option B is the correct answer. Next question number 25 ಬರ. Question number 25 ಏನಿದೆ, the radius of curvature of circular path of a charged particle in a uniform magnetic field is directly proportional to. The radius of the circular path of the charged particle is given by R is equal to mv divided by q into b. Here the radius of the circular path is directly proportional to m into v. M into v is the product of mass and velocity is the momentum p. Radius is inversely proportional to the charge of the particle and the radius of is inversely proportional to the strength of the magnetic field. In this case they have given charge of the directly proportional to ಅಂತ ಕೇಳ. ಚಾರ್ಜ್ ಆಫ್ ದ ಪಾರ್ಟಿಕಲ್ಗೆ ಇನ್ವರ್ಸ್ಲಿ ಪ್ರಪೋರ್ಷನಲ್. ಸ್ಟ್ರೆಂತ್ ಆಫ್ ದ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ಗೆ ಹೆಂಗೆ ಪ್ರಪೋರ್ಷನಲ್ ಇದೆ? ಇನ್ವರ್ಸ್ಲಿ ಪ್ರಪೋರ್ಷನಲ್. ಅಂದರೆ ಡೈರೆಕ್ಟ್ಲಿ ಪ್ರಪೋರ್ಷನಲ್ ಯಾವುದಕ್ಕಿದೆ? ಡೈರೆಕ್ಟ್ಲಿ ಪ್ರಪೋರ್ಷನಲ್ ಟು ದ ಮೊಮೆಂಟಮ್ ಆಫ್ ದಿ ಪಾರ್ಟಿಕಲ್. ಆಪ್ಷನ್ ಬಿ ಈಸ್ ದಿ ಕರೆಕ್ಟ್ ಆನ್ಸರ್. ನೆಕ್ಸ್ಟ್ ಕ್ವಶನ್ ನಂಬರ್ 26 ಬರೋಣ. ಕ್ವಶನ್ ನಂಬರ್ 26 ಏನಿದೆ? Magnitude of force acting on a conductor of length L carrying current I at an angle of theta to a magnetic field is given by. ಇವಾಗ ಒಂದು ಕಂಡಕ್ಟರ್ನ ತಗೋಣ. We'll take a conductor which is carrying a current here. This is carrying a current I here. And the length of the conductor is L. Conductor length ಎಷ್ಟು ಅಂತ ಕೊಟ್ಟಾರೆ? L ಅಂತ ಕೊಟ್ಟಾರೆ. Length of the conductor is capital L. And this conductor is placed in a magnetic field. B is the strength of the magnetic field. Then the conductor carrying current, it will experience the force when it is placed in magnetic field F. It is in magnetic field B. It is given by F is equal to I into vector L cross vector B, or else it is given by F is equal to I L B sin theta. Here option D is the correct answer. BIL sin theta. ILB sin theta or BIL sin theta. Both are same. Option D is the correct answer. Next question number 27. Force on a current carrying conductor moving in a magnetic field is given by. It is given by Fleming's left hand rule. Okay. Fleming's left hand rule, it gives the force acting on the current carrying conductor placed in the magnetic field. Here, according to this Fleming's left hand rule, the thumb indicates the direction of force acting on this conductor. Force acting on the conductor, it is given by thumb now. Forefinger, it indicates the direction of magnetic field, and the middle finger, it indicates the direction of the current. This is middle finger. Okay. Now if we place the first three fingers of the left hand mutually perpendicular to each other, this thumb, it gives the direction of the force acting on this conductor. Force acting on the conductor is given by the thumb. This forefinger, it indicates the direction of the magnetic field, and this middle finger, it will indicate the direction of the current flowing through this conductor. It is given by Fleming's left hand rule. It is used to find out the direction of force acting on this conductor, in which a current is flowing through the conductor which is placed in a magnetic field. So option B is the correct answer, Fleming's left hand rule. Next question number 28. Question number 28 ಏನಿದೆ? Force acting on the conductor carrying current placed in a uniform magnetic field will be maximum. Force ಯಾವಾಗ maximum ಇರ್ತೈತೆ ಅಂದರೆ when theta is equal to 90. Theta is equal to 90 ಇದ್ದಾಗ sin 90 ವ್ಯಾಲ್ಯೂ ಎಷ್ಟಾಗುತ್ತೆ? sin 90 ವ್ಯಾಲ್ಯೂ is equal to 1. ಆವಾಗ ಫೋರ್ಸ್ ವ್ಯಾಲ್ಯೂ ಏನಾಗುತ್ತೆ? Force becomes maximum. When theta is equal to 0 or 180. Theta is equal to 0 or 180 ಇದ್ದಾಗ sin theta ವ್ಯಾಲ್ಯೂ ಎಷ್ಟಾಗುತ್ತೆ? sin theta ವ್ಯಾಲ್ಯೂ will be equal to 0. ಆವಾಗ ಫೋರ್ಸ್ ವ್ಯಾಲ್ಯೂ ಏನಾಗುತ್ತೆ? ಮಿನಿಮಮ್. ಇವಾಗ the length of the conductor, when it is perpendicular to the magnetic field, the force becomes maximum. When the length of the conductor is parallel to the magnetic field, the force become minimum. ಅಂದರೆ ಈ ಕೇಸಲ್ಲಿ ಏನಾಗುತ್ತೆ? ಮ್ಯಾಕ್ಸಿಮಮ್ ಕೇಳಾರ. ಮ್ಯಾಕ್ಸಿಮಮ್ ಯಾವಾಗಿರುತ್ತೆ? when it is placed perpendicular to the magnetic field. Option B is the correct answer. Minimum ಕೇಳಿದ್ರೆ it is parallel to the magnetic field ಇರಬೇಕು. In this case maximum ಯಾವಾಗಿರುತ್ತೆ? Option B is the correct answer. Next question number 29 ಬರೋಣ. Question number 29 ಇದೆ, force acting on the conductor carrying current placed in a uniform magnetic field will be minimum. Minimum ಯಾವಾಗಿರುತ್ತೆ? when it is placed parallel to the magnetic field. Option A is the correct answer. Next question number 30 ಬರೋಣ. Question number 30 ಏನಿದೆ ನೋಡ್ರಿ. Question number 30, a wire PQR, wire is a PQR, okay, PQR is bent as shown in the figure and is placed in a region of uniform magnetic field. This is the direction of magnetic field. The length of PQ is equal to QR is equal to L. PQ length, QR length, both are same. L ಅಂತ ಕೊಟ್ಟರೆ length. The current I ampere flows through the wire as shown. Current is flowing here in this direction. The magnitude of the force on PQ and QR will be. Here PQ is parallel to the magnetic field. The force acting on this will be equal to 0. Similarly, QR is perpendicular to the magnetic field. QR perpendicular to magnetic field ಇದ್ದಾಗ theta value ಎಷ್ಟಾಗುತ್ತೆ? Theta value is equal to 90. Sin 90 value ಎಷ್ಟಾಯಿತು? 1 ಆಗುತ್ತೆ. Sin 90 value 1 ಆದಾಗ force will become ILB ಅಥವಾ BIL. BIL. Then the correct option will be option C, 0 and BIL. Okay, L is small here, BIL. Option C is the correct answer. Next, we will move on to question number 31. Question number 31 is nodri, the magnetic dipole moment of a current loop is independent of. The magnetic dipole moment of a current loop, it is given by M is equal to Ni into A. N is the number of turns, A is area of the loop and I is the current in the loop. That means M is depending on Nia. It is independent of the magnetic field in which it is lying. Option A is the correct answer. Option B, C and D. It is depending on number of turns, area of loop and current in the loop. But it is independent of magnetic field in which it is lying. Option A is the correct answer. Next question number 32. Question number 32 ಏನಿದೆ? A horizontal wire is carrying an electric current from north to south. A horizontal wire, it is carrying the current from north to south. Using a uniform magnetic field, it is to be prevented from falling under gravity. It should be prevented from falling under gravity. The direction of this magnetic field should be towards. Magnetic field ಯಾವ ಡೈರೆಕ್ಷನ್ ಒಳಗೆ ಇರಬೇಕಂತ ಕಂಡುಹಿಡಿರಿ ಅಂತ ಹೇಳ್ಯಾರ. Okay, now to prevent this from falling now. Okay, ಇವಾಗ this conductor is carrying the current here. The current is from north to south. This horizontal wire, it should not fall down. ಇದು ಕೆಳಗಡೆ ಬೀಳಬಾರ್ದು ಅಂತಂದರೆ ನಾವು ಫೋರ್ಸ್ ಎಲ್ಲಿ ಎಕ್ಸರ್ಟ್ ಮಾಡಬೇಕು? ಮೇಲ್ಗಡೆ ಫೋರ್ಸ್ ಇರಬೇಕು. ಓಕೆ, ಮೇಲ್ಗಡೆ ಫೋರ್ಸ್ ಇರಬೇಕಂದ್ರೆ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಡೈರೆಕ್ಷನ್ ಎಲ್ಲಿ ಇರಬೇಕು ಅನ್ನೋದನ್ನು ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕು. ಇಟ್ ಇಸ್ ಗಿವನ್ ಬೈ ಫ್ಲೆಮಿಂಗ್ಸ್ ಲೆಫ್ಟ್ ಹ್ಯಾಂಡ್ ರೂಲ್. From this left hand rule, here this thumb indicates the direction of force. This forefinger indicates the direction of magnetic field. Middle finger indicates the direction of the current here. Now we need the force in the upward direction. Force ಏನು ಇರಬೇಕು? upward direction ಅಲ್ಲಿ ಇರಬೇಕು. ಹಾಗಾದ್ರೆ ಕರೆಂಟ್ ಯಾವ ಡೈರೆಕ್ಷನ್ ಒಳಗೆ ಕೊಟ್ಟಾರೆ? ಕರೆಂಟ್ ಈಸ್ ಫ್ರಮ್ ನಾರ್ತ್ ಟು ಸೌತ್. ಕರೆಂಟ್ ಈಸ್ ಫ್ರಮ್ ನಾರ್ತ್ ಟು ಸೌತ್. ಹಾಗಾದ್ರೆ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್, current is from north to south and the magnetic field should be inwards now. For the force to be upwards, the magnetic field should be inwards. That means north, south, east, west. That means the magnetic field should be towards east. Okay, option C is the correct answer. It should be towards east. Magnetic field should be towards east. ಅದೇ ಇವಾಗ ಕರೆಂಟು ಸೌತ್ ಟು ನಾರ್ತ್ ಮೂವ್ ಆಗ್ತಾ ಇತ್ತು ಅಂತಿಕೋರಿ, ಈ ಡೈರೆಕ್ಷನ್ ಒಳಗೆ ಇತ್ತು ಅಂತಿಕೋರಿ. ಫೋರ್ಸ್ ಅಪ್ವರ್ಡ್ ಡೈರೆಕ್ಷನ್ ಒಳಗೆ ಇರಬೇಕಂತಂದರೆ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಶುಡ್ ಬಿ ಟುವರ್ಡ್ಸ್ ವೆಸ್ಟ್. ಬಟ್ ಇನ್ ದಿಸ್ ಕೇಸ್ ದ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಶುಡ್ ಬಿ ಟುವರ್ಡ್ಸ್ ಈಸ್ಟ್. ಆಪ್ಷನ್ ಸಿ ಈಸ್ ದಿ ಕರೆಕ್ಟ್ ಆನ್ಸರ್. ನೆಕ್ಸ್ಟ್ ಕ್ವಶನ್ ನಂಬರ್ 33. ಕ್ವಶನ್ ನಂಬರ್ 33 ಏನಿದೆ? A proton is projected with a velocity, uniform velocity v along the axis of a current carrying solenoid. Then here a solenoid, okay, a solenoid is an electromagnet in which it is having a helically circular coils in which a current is passed here. When the current is passed through this solenoid ಒಳಗಡೆ current pass ಮಾಡಿದಾಗ a uniform magnetic field is produced inside this solenoid and it is along the axis. The direction of magnetic field is along the axis. Now they have projected a proton here. Okay, a proton is projected with a uniform velocity v along the axis of the current carrying solenoid. Here the direction of velocity and magnetic field both are in the same direction. Okay, then theta value is equal to ಏನಾಗುತ್ತೆ 0 ಆಗ theta 0 ಆದಾಗ force acting on this proton will be equal to 0. Force acting on the proton is equal to 0 ಆದಾಗ then the proton will continue to move with a velocity v along the axis. Proton velocity increase decrease ಆಗಲ್ಲ, direction change ಆಗಲ್ಲ. The proton will continue to move with a velocity v along the axis. Option D is the correct answer. Next question number 34. Question number 34 ಏನಿದೆ? Relation between current and magnetic field produced by a current element is given by. Okay. ಇವಾಗ ಒಂದು ಕಂಡಕ್ಟರ್ ಒಳಗಡೆ ಕರೆಂಟ್ ಫ್ಲೋ ಆಗ್ತದೆ. Okay, current I is flowing. Around this conductor at some distance, we will take a distance r, a magnetic field is produced. This magnetic field produced, it is directly proportional to I into dl. I into dl, here dl is the small length. I into dl, it is called as the current element. This length and the current which is flowing through this length, it is called as a current element. The magnetic field produced at some distance is directly proportional to I into dl. This magnetic field produced is directly proportional to sin theta. Here theta is the angle between distance vector r from the direction of the current. Distance vector r from the direction of current, and the strength of the magnetic field is inversely proportional to the square of the distance from this point where we are finding the magnetic field and the current element. Illinda illi distance inversely proportional to square of the distance. Then we get Biot-Savart's law, dB is equal to mu naught divided by 4 pi I dl sin theta divided by r square. This is the expression for Biot-Savart's law. Okay, the relation between current and magnetic field produced by a current element is given by Biot-Savart's law. Option C is the correct answer. Next question number 35 ಬರೋಣ. Question number 35 ಇದೆ, an expression for magnetic field on the axis of a circular current loop. Now if I take a circular current loop along the axis of the circular current loop, the magnetic field produced is given by B is equal to mu naught divided by 4 pi 2 pi I r square divided by r square plus x square whole raised to 3 by 2. Now this is a coil. This coil is carrying a current I here along the axis at some distance x here. From the center of the coil there is a magnetic field is produced, and this magnetic field is along the axis. ಈ ಆಕ್ಸಸ್ ಯಾವುದಿಲ್ಲ, ಆ ಆಕ್ಸಸ್ ಡೈರೆಕ್ಷನ್ ಒಳಗಡೆ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್. ದಟ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಇಸ್ ಗಿವನ್ ಬೈ ಬಿ ಇಸ್ ಈಕ್ವಲ್ ಟು ಮ್ಯೂ ನಾಟ್ ಡಿವೈಡ್ ಬೈ 4 pi 2 pi I r square divided by r square plus x square whole raised to 3 by 2. Option A is the correct answer. Next question number 36 ಬರೋಣ. Question number 36 ಏನಿದೆ, magnetic field produced by a circular coil carrying current is maximum. This circular coil is carrying the current here. Where is the magnetic field maximum, they have asked. For the magnetic field to be maximum, the value of x should be minimum. X value irbeku, minimum irbeku. Here r is the radius of the circular coil. I is the current flowing through the coil. When x is equal to 0, x value 0 ಆಯ್ತು ಅಂತಂದ್ರೆ magnetic field will be maximum. X value 0 ಅಂತಂದ್ರೆ this point should come here at the center of the coil. The magnetic field will be maximum at the center of the coil. Option A is the correct answer. At the center of the coil, x is equal to 0. X is equal to 0 substitute ಮಾಡಿದಾಗ we get the value of B is equal to B value ಏನಾಗುತ್ತೆ mu naught I divided by 2R. When you simplify this equation, at the center of the circular coil we get magnetic field mu naught I divided by 2R. Okay, ಹಾಗಾದ್ರೆ ಇಲ್ಲಿ option A is the correct answer. Okay, ಇವಾಗ question number 37 ನೋಡೋಣ. Question number 37 ಏನಿದೆ? The line integral of closed integral vector B dot vector dl. Closed integral of vector B dot vector dl is equal to, in a closed curve is equal to, it is equal to mu naught times the current through the area bounded by the curve. That is the ampere circuit law. Ampere circuit law ಪ್ರಕಾರ ಇದೆ closed integral of vector B dot vector dl is equal to ಏನಿದೆ mu naught into I. Option C is the correct answer. Next question number 38 ಬರ. Question number 38 ಏನಿದೆ magnetic field due to an infinitely long straight current carrying wire at a distance r outside is given by. Okay, now if I take an infinitely long conductor which is carrying the current I here, the magnetic field around this conductor at a distance r, okay, at a distance r, it is given by B is equal to mu naught I divided by 2 pi r. This magnetic field at a distance r, it is given by mu naught I divided by 2 pi r. It is inversely proportional to the distance from the wire to the point where we are finding the magnetic field. That means it is inversely proportional to r. Option B is the correct answer. Next question number 39. Question number 39 is an expression for magnetic field due to a straight conductor of infinite length carrying current using ampere circuit law is given by B is equal to mu naught I divided by 2 pi r. Option A is the correct answer. Next question number 40. Question number 40 ಏನಿದೆ magnetic field due to an infinitely long solenoid is. Now if I take a solenoid, okay, infinitely long solenoid, in this solenoid the magnetic field inside the solenoid is uniform and it is along the axis inside the solenoid, and outside the solenoid the magnetic field is very weak and it is divergent. Inside the solenoid the magnetic field is uniform and it is along the axis. Option A is the correct answer. Next question number 41. Question number 41 is magnetic field due to an infinitely long solenoid is given by B is equal to mu naught n I. Here mu naught is permeability of free space, n is the number of turns per unit length, I is the current flowing through this coil now or this solenoid. Here they have asked how is this magnetic field depending on the current now. The magnetic field is directly proportional to the current through the solenoid. Option A is the correct answer. Next question number 42. Question number 42. Question number 42. Magnetic field inside a solenoid is given by mu naught is permeability of vacuum, n is number of turns per unit length, I is current through the solenoid. It is given by B is equal to mu naught n I. Option B is the correct answer. Next question number 43. Question number 43. Here the nature of force between two parallel and two anti-parallel straight current carrying conductors are. Now they have given two conductors which are carrying the current in the same direction parallel and two conductors which are carrying the current in opposite direction. Now we have to find out the force between these two conductors. Okay, ಎರಡು ಕಂಡಕ್ಟರ್ಸ್ ಮಧ್ಯೆ ಫೋರ್ಸ್ ಯಾವ ರೀತಿ ಇದೆ. This is first case and this is the second case. When the conductors are carrying the current in the same direction. Now this conductor is carrying the current I ಅಂತ ತಗೋಣ I1. This conductor is carrying the current I2. This is I1, this is I2. Here, this conductor will produce a magnetic field around this. Okay, this conductor sutlu enagutte magnetic field produce agutte. The direction of magnetic field is given by right hand thumb rule. If we hold the conductor in our right hand, the extended thumb gives the direction of the current, and this direction in which we are closing our fingers gives the direction of the magnetic field. We are holding the conductor, this is the direction of current and this is the direction of magnetic field. Okay, hangare current upward direction agate, magnetic field enagutte in this direction. So at this point the magnetic field is in this direction, produced by this conductor B1. Hangidre conductor, second conductor is carrying the current I2. Magnetic field is B1. The force acting on this conductor can be found out by Fleming's left hand rule. Thumb indicates the direction of force, forefinger indicates the direction of magnetic field, middle finger indicates the direction of the current. Here the current is in the upward direction. Current in the upward direction. Magnetic field in the inward, towards the board, inward direction. Current upwards, magnetic field inward. The force will be in this direction. This is the direction of force acting on the second conductor. On the second conductor, force E direction. Now we find out the force on the first conductor. The second conductor is carrying the current I2. Current is in the upward direction. The magnetic field will be in this direction. Okay, curled fingers. Magnetic field E direction barutide. Hangidre enagutte, magnetic field is in this direction. We get the magnetic field here. Okay, outwards barutide, towards outside the board. Hangidre the force acting on this conductor can be found out by Fleming's left hand rule. Current is upwards. Current is in this direction, upwards. Current melgade. Magnetic field is outwards, E direction. Current upwards, magnetic field outwards, force will be in this direction. That means the forces are towards each other. There is a force of attraction when the conductors are carrying the current in the same direction. Similarly, when the conductors are carrying the current in the opposite direction, current upwards iddaga magnetic field enagutte E direction barutade. This is B1. Magnetic field is inwards, current is downwards. Current is downward. Current is downwards. Magnetic field is inward. Magnetic field inward aiti, current to downward. Force yav direction barutade? E direction barutade. Force is in this direction. Current is downwards, hangare magnetic field enagutte E direction. Okay, magnetic field is in this direction. Magnetic field yav direction barutade? E direction barutade. Magnetic field is inwards, current yav direction agide? Upwards. Current upwards, hangare force yav direction? E direction barutade. Force is in this direction. There is a force of repulsion. When the current in the two conductors are in the same direction, there is a force of attraction. When the current in the conductors are in the opposite direction, then there is a force of repulsion between the two conductors. Hangidre illi enagutte? Option E. Attractive when the currents are parallel, and repulsive when the currents are anti-parallel. Option A is the correct answer. Next question number 44. Question number 44 is two infinitely long straight parallel conductors each carrying current of 1 ampere. Okay, I1 is equal to I2 is equal to 1 ampere ant kotar. In the same direction, kept separated by a distance of 1 meter. Edra madhye distance eshtiде 1 meter ant kotar. In air, then when the conductors are carrying the current in the same direction, there will be a force of attraction. Okay, both will attract each other. Now we have to find out the force per unit length. Force per unit length, it is given by mu naught I1 I2 divided by 2 pi d here. force per unit length is given by mu naught value is 4 pi into 10 raised to minus 7. I1 I2 equal to 1 ಅಂತ ಕೊಟ್ರೆ 1 into 1 divided by 2 pi d is equal to ಎಷ್ಟು ಕೊಟ್ರೆ 1 ಅಂತ ಕೊಟ್ರೆ. So pi will get cancelled. 2 ones are 2 twos are. We'll get 2 into 10 raised to minus 7. Force unit is Newton. Length unit is meter. Newton per meter. The force per unit length will be equal to 2 into 10 raised to minus 7 Newton per meter, and the force will be attractive. So they will attract each other with a force of 2 into 10 raised to minus 7 Newton per meter. Option A is the correct answer. ಇವಾಗ question number 45 ಇದೆ. Question number 45, an expression for torque on rectangular current loop in a uniform magnetic field is. Now if I take a rectangular current loop, this rectangular current loop is carrying the current in this direction. Now this rectangular current loop will experience a torque here. This torque is given by vector m cross vector b, where m is the magnetic moment and b is the strength of the magnetic field. Tau is given by tau is equal to vector m cross vector b. Option A is the correct answer. Next question number 46 ಬರೋಣ. Question number 46 ಏನಿದೆ? Torque acting on a current loop is maximum. In this current loop, the torque acting on the current loop will be maximum when the plane of the coil is parallel to the uniform magnetic field. ಈ plane of the coil ಹೆಂಗಿರಬೇಕಂದ್ರೆ uniform magnetic field ಹೆಂಗಿರಬೇಕು? Parallel. The plane of the coil and the magnetic field should be parallel. ಎರಡು parallel ಇದ್ರೆ tau value ಏನಾಗುತ್ತೆ? Tau value will be maximum. Tau is maximum when the plane of the coil is parallel to the magnetic field, and tau is minimum when the plane of the coil is perpendicular to the uniform magnetic field. ಇಲ್ಲಿ ಕೇಳಿರೋದೇನೋ maximum ಕೇಳಾರೆ. So option A is the correct answer. Plane of the coil is parallel to the magnetic field. Next question number 47. Question number 47. A rectangular coil carrying current is placed with its plane making an angle of 90 degree with the magnetic field. Now the torque acting on it is, ಈಗ perpendicular to magnetic field ಇರೋದ್ರಿಂದ torque acting on the rectangular loop will be equal to 0. Option A is the correct answer. Okay, perpendicular ಇದ್ರೆ torque value ಏನಾಗುತ್ತೆ? 0 ಆಗ್ತದೆ. Next question number 48. Question number 48 ಏನಿದೆ? A current loop placed in uniform magnetic field, theta is not equal to 0 or 90 degree or 180 degree. ಇವಾಗ ಈ torque acting on this loop. Now we'll take a magnetic field is acting on this rectangular current loop. ಇವಾಗ ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ? In this case the current are in opposite direction. Current opposite direction ಒಳಗೆ ಇರೋದ್ರಿಂದ forces are also acting in the opposite direction and they are acting along the same line. Force ಏನಾಗ್ತಾ ಇದೆ? ಸೇಮ್ ಲೈನಲ್ಲಿ ಮತ್ತು opposite direction ಒಳಗೆ ಆ್ಯಕ್ಟ್ ಆಗ್ತಾ ಇದೆ. ಸೊ net force along the vertical is equal to ಏನಾಗುತ್ತೆ? 0 ಆಗ್ತದೆ. and net force along the horizontal, ಇವಾಗ this is also carrying the current in the opposite direction. There is a forces in the opposite direction. one force ಏನಾಗ್ತಾ ಇದೆ? ಈ ಡೈರೆಕ್ಷನ್ ಒಳಗೆ, ಇನ್ನೊಂದು ಫೋರ್ಸ್ ಏನಾಗ್ತದೆ? ಈ ಡೈರೆಕ್ಷನ್ ಒಳಗೆ ಆ್ಯಕ್ಟ್ ಆಗ್ತದೆ. ಓಕೆ, ಬೋತ್ ದ ಫೋರ್ಸಸ್ ಆರ್ ಆ್ಯಕ್ಟಿಂಗ್ in the opposite direction, but they are not acting along the same line ಮೇಲೆ ಇಲ್ಲ. So it produces a rotational effect. Okay, tau is not equal to 0. That means it is producing a rotational effect, but the net force is equal to 0 ಆಗ್ತೈತಿ. Now we have the expression for force. Force is equal to ಏನಿದೆ? ILB sin theta. ಇವಾಗ I is same, ಇದ್ರೊಳಗೆ ಫ್ಲೋ ಆಗ್ತಾ ಇರೋಂಥ ಕರೆಂಟ್, ಇದ್ರೊಳಗೆ ಫ್ಲೋ ಆಗ್ತಾ ಇರೋಂಥ ಕರೆಂಟು ಸೇಮ್ ಇದೆ. L is same. For rectangular loop the length, okay, opposite sides ಏನಿರುತ್ತೆ? ಸೇಮ್ ಇರ್ತದೆ. Magnetic field is also same. B is the strength of the magnetic field. Uniform magnetic field anta kottara. Uniform magnetic field kottaga both the forces are equal and in opposite direction. Avaga net force value enagutte 0. Force is 0 but torque is not equal to 0. ಎರಡು ಫೋರ್ಸ್ ಈಕ್ವಲ್ ಆ್ಯಂಡ್ ಅಪೋಸಿಟ್ ಇರೋದ್ರಿಂದ ದೇರ್ ಇಸ್ ಅ ರೊಟೇಷನಲ್ ಎಫೆಕ್ಟ್ ಈಸ್ ಪ್ರೊಡ್ಯೂಸ್ಡ್. ಓಕೆ, ಟಾರ್ಕ್ ಈಸ್ ಪ್ರೊಡ್ಯೂಸ್ಡ್. ಬಟ್ ಇಫ್ ದ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಈಸ್ ನಾಟ್ ಯೂನಿಫಾರ್ಮ್, ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಯೂನಿಫಾರ್ಮ್ ಇಲ್ಲ ಅಂದರೆ ಇಲ್ಲೇ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಬೇರೆ, ಇಲ್ಲೇ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಬೇರೆ ಆದಾಗ ಬೋತ್ ದ ಫೋರ್ಸಸ್ ವಿಲ್ ಬಿ ಡಿಫ್ರೆಂಟ್. ನೆಟ್ ಫೋರ್ಸ್ ವಿಲ್ ನಾಟ್ ಬಿ ಈಕ್ವಲ್ ಟು 0. ನೆಟ್ ಫೋರ್ಸ್ ವಿಲ್ ಬಿ 0 ವೆನ್ ದಿಸ್ ಕರೆಂಟ್ ಕ್ಯಾರಿಂಗ್ rectangular loop is placed in uniform magnetic field, and force is not equal to 0 when it is not placed in uniform magnetic field. Okay, hangare illi enagutte, but in both the cases the torque will not be equal to 0 whether this rectangular coil is placed in uniform magnetic field or non-uniform magnetic field. The torque will always be produced. Okay, in this case a current loop placed in a uniform magnetic field will experience only torque in uniform magnetic field. In non-uniform magnetic field, it will experience force as well as the torque is produced. Next to question number 49. Question number 49. Question number 49. Net force acting on the circular current loop placed in a uniform magnetic field. Net force ಏನಾಗುತ್ತೆ? Net force is equal to ಏನಾಗುತ್ತೆ? 0. Net force is equal to 0. Option D is the correct answer. Next question number 50. Question number 50 ಏನಿದೆ? Question number 50. Sensitivity of a galvanometer can be increased. The sensitivity of the galvanometer is given by I is equal to theta divided by I. Theta is given by NBA divided by C. I by theta is given by, sorry, theta by I is given by NBA divided by C. The sensitivity of the galvanometer is the deflection produced per unit current. It is given by NBA divided by C here. Here K is directly proportional to N, K is directly proportional to B, K is directly proportional to A. N is number of turns, B is the strength of magnetic field, A is the area of the coil, and C is the torsional constant here. K is inversely proportional to C. ಹಾಗಿದ್ರೆ K ವ್ಯಾಲ್ಯೂ ಇನ್ಕ್ರೀಸ್ ಮಾಡಬೇಕಂದ್ರೆ, N, B and A should be increased, C should be decreased. ಹಾಗಾದರೆ ಇಲ್ಲಿ ಕೊಟ್ಟಿರೋಂಥ ಆಪ್ಷನ್ ಒಳಗೆ ಏನಿದೆ? ಫಸ್ಟ್ ಆಪ್ಷನ್ ಎ ಏನಿದೆ? ಇನ್ಕ್ರೀಸಿಂಗ್ ದ ನಂಬರ್ ಆಫ್ ಟರ್ನ್ಸ್. ಕೆನ ಇನ್ಕ್ರೀಸ್ ಮಾಡಬೇಕಂದ್ರೆ ನಂಬರ್ ಆಫ್ ಟರ್ನ್ಸ್ನ ಏನು ಮಾಡಬೇಕು? ಇನ್ಕ್ರೀಸ್ ಮಾಡಬೇಕು. ಆಪ್ಷನ್ ಎ ಇಸ್ ಕರೆಕ್ಟ್. ಆಪ್ಷನ್ ಬಿ ನೋಡೋಣ, ಡಿಕ್ರೀಸಿಂಗ್ ದ ಏರಿಯಾ ಆಫ್ ದ ಕಾಯಿಲ್. ಏರಿಯಾ ಆಫ್ ದ ಕಾಯಿಲ್ ಡಿಕ್ರೀಸ್ ಮಾಡಿದ್ರೆ ಕೆನೂ ಡಿಕ್ರೀಸ್ ಆಕೈತಿ. ಆಪ್ಷನ್ ಬಿ ಇಸ್ ರಾಂಗ್. ಆಪ್ಷನ್ ಸಿ ಏನಿದೆ? ಡಿಕ್ರೀಸಿಂಗ್ ದ ಸ್ಟ್ರೆಂತ್ ಆಫ್ ದ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಬಿಟ್ವೀನ್ ದ ಪೋಲ್ ಪೀಸಸ್. ಬಿನ ಡಿಕ್ರೀಸ್ ಮಾಡಿದ್ರೆ ಕೆನು ಏನಾಗುತ್ತೆ? ಡಿಕ್ರೀಸ್ ಆಗುತ್ತೆ. ಆಪ್ಷನ್ ಸಿನೂ ರಾಂಗ್ ಇದೆ. ಆಪ್ಷನ್ ಡಿ ಏನಿದೆ? ಇನ್ಕ್ರೀಸಿಂಗ್ ದ ಟಾರ್ಷನಲ್ ಕಾನ್ಸ್ಟೆಂಟ್. ಟಾರ್ಷನಲ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಆಫ್ ದ ಸ್ಪ್ರಿಂಗನ್ನು ಇನ್ಕ್ರೀಸ್ ಮಾಡಿದರೆ ಕೆ ವ್ಯಾಲ್ಯೂ ಏನಾಕೈತಿ? ಡಿಕ್ರೀಸ್ ಆಕೈತಿ. ಅಂದರೆ ಈ 4 ಕೇಸ್ ಒಳಗಡೆ ಕೆ ವ್ಯಾಲ್ಯೂ ಇನ್ಕ್ರೀಸ್ ಮಾಡಬೇಕಂದ್ರೆ ಇನ್ಕ್ರೀಸಿಂಗ್ ದ ನಂಬರ್ ಆಫ್ ಟರ್ನ್ಸ್. ಆಪ್ಷನ್ ಎ ಈಸ್ ದಿ ಕರೆಕ್ಟ್ ಆನ್ಸರ್. ನೆಕ್ಸ್ಟ್ ಕ್ವಶನ್ ನಂಬರ್ 51. ಕ್ವಶನ್ ನಂಬರ್ 51 ಏನಿದೆ? ಕರೆಂಟ್ ಫ್ಲೋಯಿಂಗ್ through a circuit can be detected using, okay, on circuit ಒಳಗಡೆ ಕರೆಂಟ್ ಫ್ಲೋ ಆಗ್ತಾ ಇರೋದನ್ನ ಡಿಟೆಕ್ಟ್ ಮಾಡೋಕ್ಕೆ we can use a galvanometer. Option B is the correct answer. Next question number 52. Question number 52 ಏನಿದೆ? For a galvanometer, deflection per unit current is called. Deflection per unit current is called as current sensitivity. Option B is the correct answer. Next question number 53. Question number 53. To convert galvanometer into voltmeter, one should connect. Now, if you want to convert a galvanometer into a voltmeter, we have to connect a high resistance in series. Okay, when you connect a galvanometer to high resistance in series, this galvanometer will get converted into a voltmeter. Similarly, if you want to convert a galvanometer into ammeter, we have to connect a low resistance that is called as a shunt resistance in parallel. Then this will become an ammeter. To convert a galvanometer into voltmeter, we have to connect a high resistance in series. Similarly, to convert a galvanometer into ammeter, we have to connect a low resistance in parallel. Okay, ಇಲ್ಲಿ ಏನು ಕೊಟ್ಟಿದ್ದಾರೆ, to convert a galvanometer into voltmeter, one should connect a high resistance in series with galvanometer. Option A is the correct answer. Next question number 54 ಬರೋಣ. Question number 54, a galvanometer is converted into ammeter by connecting a, okay, to convert it into ammeter, we have to connect a low resistance in parallel with it. Option D is the correct answer. Next, question number 55. Question number 55, range of ammeter can be increased. Ammeter range na increase ಮಾಡಬೇಕಂತಂದ್ರೆ, ammeter range na increase ಮಾಡಬೇಕಂದ್ರೆ we have to decrease the resistance. Shunt resistance value ಏನು ಮಾಡಬೇಕು, decrease ಮಾಡಬೇಕು. When S decreases, okay, the range of ammeter value also increases. Okay, the ammeter range can be increased by decreasing the shunt resistance value. Or else we can increase by connecting one more low resistance in parallel. ಇನ್ನೊಂದು ಲೋ ರೆಸಿಸ್ಟೆನ್ಸನ್ನು ಪ್ಯಾರಲಲ್ ಕನೆಕ್ಟ್ ಮಾಡಿದ್ರೂ ಅಮೀಟರ್ ರೇಂಜ್ ನಾವೇನು ಮಾಡ್ಬೋದು, ಇನ್ಕ್ರೀಸ್ ಮಾಡ್ಬೋದು. ಹಾಗೆ ಇಲ್ಲಿ ಕೊಟ್ಟಿರೋಂಥ ಕೇಸಲ್ಲಿ ಏನಿದೆ, ಇನ್ಕ್ರೀಸಿಂಗ್ ದ ವ್ಯಾಲ್ಯೂ ಆಫ್ ಶಂಟ್ ರೆಸಿಸ್ಟೆನ್ಸ್ನ ಇನ್ಕ್ರೀಸ್ ಮಾಡಿದರೆ ಅಮೀಟರ್ ರೇಂಜ್ ಏನಾಕೈತಿ, ಡಿಕ್ರೀಸ್ ಆಕೈತಿ. ಡಿಕ್ರೀಸಿಂಗ್ ದ ವ್ಯಾಲ್ಯೂ ಆಫ್ ಶಂಟ್ ರೆಸಿಸ್ಟೆನ್ಸ್, ದ ಅಮೀಟರ್ ರೇಂಜ್ ವಿಲ್ ಇನ್ಕ್ರೀಸ್. ಆಪ್ಷನ್ ಸಿ ಏನು ಕೊಟ್ಟರೆ, ಕನೆಕ್ಟಿಂಗ್ ಅನದರ್ ಲೋ ರೆಸಿಸ್ಟೆನ್ಸ್ ಇನ್ ಸೀರೀಸ್ ಅಂತ ಕೊಟ್ಟರೆ, ಇನ್ನೊಂದು ಲೋ ರೆಸಿಸ್ಟೆನ್ಸ್ನ ಸೀರೀಸ್ ಕನೆಕ್ಟ್ ಮಾಡಿದರೆ ದ ಎಫೆಕ್ಟಿವ್ ರೆಸಿಸ್ಟೆನ್ಸ್ ಇನ್ಕ್ರೀಸಸ್. ಎಫೆಕ್ಟಿವ್ ರೆಸಿಸ್ಟೆನ್ಸ್ ಇನ್ಕ್ರೀಸ್ ಆದರೆ ಇದರ ರೇಂಜ್ ಏನಾಕೈತಿ, ಡಿಕ್ರೀಸ್ ಆಕೈತಿ. ಆಪ್ಷನ್ ಸಿ ಈಸ್ ಆಲ್ಸೋ ರಾಂಗ್. ಓಕೆ, ಸ್ಟ್ರೆಂತ್ ಆಫ್ ದ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಬಿಟ್ವೀನ್ ದ ಪೋಲ್ಸು, ದಟ್ ಈಸ್ ಆಲ್ಸೋ ರಾಂಗ್. ಇಲ್ಲ ಹಂಗಿದ್ರೆ ಏನು ಮಾಡಬೇಕು, ವಿ ಹ್ಯಾವ್ ಟು ಡಿಕ್ರೀಸ್ ದ ವ್ಯಾಲ್ಯೂ ಆಫ್ ಶಂಟ್ ರೆಸಿಸ್ಟೆನ್ಸ್. ಆಪ್ಷನ್ ಬಿ ಈಸ್ ದಿ ಕರೆಕ್ಟ್ ಆನ್ಸರ್. ನೆಕ್ಸ್ಟು ಕ್ವಶನ್ ನಂಬರ್ 56 ಬರ. ಕ್ವಶನ್ ನಂಬರ್ 56, the range of voltmeter can be increased. Voltmeter ರೇಂಜನ್ನು ಇನ್ಕ್ರೀಸ್ ಮಾಡಬೇಕಂದ್ರೆ the resistance value which is connected in series, that should be increased. Okay, resistance value ಏನು ಮಾಡಬೇಕು, increasing the value of series resistance ನ ಇನ್ಕ್ರೀಸ್ ಮಾಡಬೇಕು. ಅಥವಾ we have to connect another resistance in series. Okay, ಇನ್ನೊಂದು ರೆಸಿಸ್ಟೆನ್ಸ್ನ ಸೀರೀಸಾಗಿ ಕನೆಕ್ಟ್ ಮಾಡಿದ್ರು ನಾವೇನು ಮಾಡ್ಬೋದು, we can increase the voltmeter range. ಹಾಗಾದ್ರೆ ಇಲ್ಲಿ ಕೊಟ್ಟಿರೋಂಥ ಆಪ್ಷನಲ್ಲಿ ಏನಿದೆ, ಇನ್ಕ್ರೀಸಿಂಗ್ ದ ವ್ಯಾಲ್ಯೂ ಆಫ್ ಸೀರೀಸ್ ರೆಸಿಸ್ಟೆನ್ಸ್. ಆಪ್ಷನ್ ಎ ಇಸ್ ದ ಕರೆಕ್ಟ್ ಆನ್ಸರ್. ಇಲ್ಲಿ ಸೀರೀಸ್ ರೆಸಿಸ್ಟೆನ್ಸ್ ವ್ಯಾಲ್ಯೂ ಡಿಕ್ರೀಸ್ ಮಾಡಿದ್ವಿ ಅಂತಂದರೆ ವೋಲ್ಟ್ ಮೀಟರ್ದು ರೇಂಜ್ ಏನಾಗುತ್ತೆ, ಅದು ಡಿಕ್ರೀಸ್ ಆಗ್ತೈತೆ. ಓಕೆ, ಕನೆಕ್ಟಿಂಗ್ ಅನದರ್ ಹೈ ರೆಸಿಸ್ಟೆನ್ಸ್ ಇನ್ ಪ್ಯಾರಲಲ್, ಇನ್ನೊಂದು ರೆಸಿಸ್ಟೆನ್ಸನ್ನು ಪ್ಯಾರಲಲ್ ಕನೆಕ್ಟ್ ಮಾಡಿದರೆ ಎಫೆಕ್ಟಿವ್ ರೆಸಿಸ್ಟೆನ್ಸ್ ಏನಾಗುತ್ತೆ, ಡಿಕ್ರೀಸ್ ಆಗ್ತೈತೆ. ಸೊ here the correct option is option A, increasing the value of series resistance. Okay, this completes this chapter. Okay, thank you.